Warm greetings to dear students and friends. Today I am going to deliver a lecture video on the shear stress and bending moment for a cantilever beam of span 2 meter, which is subjected to an UDL intensity of 10 kilonewton per meter and over the span of 2 meter, that is for the entire span. So what will be the maximum shear force and maximum bending moment? What is the shear stress and bending stress for a maximum moment and shear force which is occurring? So the maximum shear force and bending moment which occurs at the fixed end, that I call it as left support A, right? This is a cantilever beam which is having a fixed at this point and free at this, and UDL is acting on this of 10 kilonewton per meter and which is of 2 meter span. So here the maximum reaction is W into L, that is 10 into 2, that is equal to 20 kilonewton, which just occurs at the support A. And the shear force will be a maximum of fixed support, which is also 10 into 20, that is 20 kilonewton. So 0 at the free end and maximum shear force at the fixed end, which is of 20 kilonewton, which is a positive shear force. Now the maximum shear stress is equal to the maximum shear force divided by the value of the corresponding area. So if it is a rectangular beam which is of width 300 mm and depth of 500 mm, so the maximum shear stress is equal to tau max, that is equal to 3 by 2 into Q average, that is equal to 3 by 2 into Q average is nothing but the shear force is, maximum shear force is 20 kilonewton, so 20 into 10 power 3, converting kilonewton to newton, divided by area is 300 into 500. Then the maximum shear stress is equal to 3 by 2 into 20 into 10 power 3 divided by 300 into 500. So whatever the value you are getting in terms of the unit of Newton per square millimeter. So this is about the maximum shear stress. So it is occurs at the fixed end. Then similarly, what about the maximum bending stress? The maximum bending stress will occur at the fixed point only, that is at support A, so which is of 20 into 2 square by 2. So it is nothing but 40 kilonewton meter. So this 40 kilonewton is the maximum bending moment. So due to this maximum bending moment, you will get the maximum bending stress. Sigma max is equal to m by I into y max. So from the pure bending equation for the first and second term. So that is the modified equation. Sigma max is equal to m by I into y max. Here m is equal to maximum bending moment or the moment of resistance, that is equal to 40 into 10 power 6 because of kilonewton meter to Newton millimeter. 40 into 10 power 6 divided by I is what? 300 width. So 300 into 500 cube by 12 into the y max, which is of the section 500 depth of the beam. So y max is equal to 500 by 2, that is something but 250 mm. So in that case m by I into 250, so m is 40 into 10 power 6 divided by 300 into 500 cube by 12 bracket into which is of 250. So you will get the maximum bending stress value, it is of Newton per square millimeter. If you are solving is equation sigma max, you will get the bending stress of the maximum value which occurs at the top fiber of the beam. For example, so this is the rectangular beam. For example, top fiber and bottom fiber, the central point is the middle of this centroid. So neutral axis, the bending stress sigma is equal to 0. So here it is also maximum. Cantilever beam means the tensile stress. The maximum tensile stress is the value what I have told you, 3 by 2 strength 3 by 2 that for the shear stress. Bending stress is M by I into I max. So we have calculated before a minute back. So at the top fiber you will get maximum tensile stress. At the bottom fiber you will get the maximum compressive stress. So at the neutral axis, at the centroid of this rectangular section, the bending stress is 0. So maximum value will occur at the topmost and bottommost fiber. Because of cantilever, you will get the maximum tensile is here. Here, maximum compressive stress in terms of bending will occur. So like that, you can find at any depth. So for example, when y is equal to 100 millimeter, when y is equal to below 200 mm from the neutral axis, m equal to, you can get at 150 mm. Here also 150 mm. But it is of the symmetrical value, same value, but the tensile and compressive will be there in the case of nature of the bending stress. So this is about the calculation of the shear stress and bending stress in the case of cantilever beam with a rectangular beam, which is of 300 mm by 500 mm breadth and depth. So with this, the calculation of maximum bending stress and maximum shear stress, and you can also draw the bending stress and shear stress distribution across the cross section of the beam. So thank you very much for patient listening. Thank you very much, and God bless. Thank you.